Okay, this is lecture 10, example 1. I thought I would throw in a programming example. It's a good example, has some cool tricks in it that typically used quite often. There's kind of a theory behind it too, which I want to discuss. I'm actually going to try to do this program written in typing it out rather than handwriting it, and we'll see how that goes. But the problem is, go to memory, check 5 unsigned byte locations. So they're bytes, and I'm looking at those. I'm trying to find the largest piece of data in there. Find the largest value in those 5 bytes starting at the address in x10. So I'm going to memory, looking at 5 locations starting at x10, and I'm going to return the largest value back in register x10. So I'm sending it the address in x10, which is that's what I'm passing, but I'm actually passing back maybe like a return value. I'm actually passing back that large piece of data in x10. So along the way, it says don't allow the subroutine to permanently change any registers other than x10. So that essentially means I need to save context on this, which is saving all the registers I use at the beginning of the subroutine and then popping them off at the end of the subroutine. So being a good citizen here, I'm going to start off with a flowchart, and so let's do it. Looks like I got the wrong thing again. This is my find the largest value. I know from looking at the program I need to save context, and then practically with every subroutine there is, I have some initialization stuff. This is being no different, and we'll talk about that in a second. And other than that, this program works very nicely as a do-while. This feels more like a do-while loop. And so what I'm going to do here is model it as a do-while. And I know it's okay to do this because I'm always going to do this 5 times. So I'll say get data, and then I am going to see data largest. If it's not, I'm going to do some loop admin. And then and this is the while part of my loop, I'll just say loop done. That's a done. No. But if the loop is done, I can restore context and return. And so, yeah, I didn't draw this very well. That's okay. But if it is, no, it's not the loop done part. Yes. We forgot this one. Okay, so the issue is if it is the new lowest data, I've got to I gotta save it. We'll just say save. Save largest data. And then I'm gonna do the loop admin. Okay, so that's what I got. So it's modeled like a do-while loop. It does have an if. It's a do-while loop. Does have a if then else embedded in the middle of it. So I think at that point I'm gonna call it done, and I'm going to switch over to the RARS assembler, hopefully, and not the RARS. That's not it. And so I'm gonna call that it. And so let me fix this. Okay, that was a little trick there, so I think I got it ready to go. And I am going to put this down and hopefully start typing, and hopefully it gets everything happy on this thing. I kind of know what the flowchart looks like, so we'll kind of go through it longhand on this thing, but let's do it. Okay, so this, like I said, typically this is the way I write programs. And so let's see, I don't remember what I called it. Something like find large. Okay, looks good. And all these programs have some type of initialization sequence, this program being no different. But I'm going to, I don't know what I'm going to do here. It needs to save context first, and I don't know what registers I need yet, so I'm going to save this till the end. Maybe I'll put a note out there. In fact, that's such a good note. There's my save contest. I'll put a whole note there. So remember to do that later, and I can come back to that. So the initialization part is the issue of this is a loop. I have to do it 5 times. So I'm just going to load some random register with a 5. Doesn't matter which one I do. 5, okay, and so the other thing I need to do in here is I want to keep this subroutine really generic, so I want to start this, I'm going to, you know, technically speaking, I could compare the first 2 values, but that would make it kind of hard to do. It would make it have like a special case in it. I don't want to do that. So what I want to do is make up a dummy small value, and what I'm going to do is call x20 x0. So I'm going to move x20 into 0. I'll put a note there. Largest is not the letter. Largest loop count. Okay, so that's going to help us out there. So x20, go away, red line, looks good. And okay, so I think I'm ready to go on this thing. I'm ready to go get some data. The data is a load word, load byte, it's unsigned. I'll stick it somewhere, x21. The address is 0, and it sent me an x10. Okay, so I'm going to move these over just to make it look beautiful. Get data. Okay, so that means I've got the data in x21 right now, and I'm going to compare it to x20. So I'm going to say, get a phone call here. Okay, back to the problem. Like 15 minutes later after the phone rang. I'll probably leave that in there, no big deal. So at this point, after I get some data, I need to look at it, and I'll put it on the same line. Essentially, I have data. The old data, which I considered the largest data, is an M20, and I want to see if my new data is less than that. So what I'm going to do is branch away to the loop admin if the data in x20 is less than just the data I got. I'm going to jump x20, x21. And I'm going to jump to admin. This is my loop admin. BLT. And it needs an admin. Okay, so I'll worry about that later. I want the red to go away. Okay, there's my admin. Okay, so this is the admin, and what I'm going to do here for the admin is I need to do a couple things. I for sure need to decrement the loop count, which is x15. Okay, and we'll put that in there. And I also need to increment the address value, ADD x10. I'm increment it by 1 because these are bytes that I'm working with, and then I need to check it. So this is the while part of the while loop, BEQ x15 and x0. If it's done, I am going to heck I don't like that. I'm gonna use something else, and I'm gonna go Actually, I don't know this, so right now I'm looking at my cheat sheet. I want to say branch if not equal to 0. And I know there's a BNE. So, and I think what you're going to see is that I did the instruction in the solution a little bit differently, and this is actually makes a lot more sense because it's one less instruction. Okay, and that means if that's not equal to, if it's not equal to 0, the loop is not equal to 0, I'm sorry, if the iteration value is not equal to 0, I'm jumping back to loop. Otherwise, I'm going to drop out of this subroutine, and when I drop out of it, it's going to be I'm going to restore the context. Okay, and I still don't know what I'm doing on that one, so not a big deal. And so everything looks good, except I need to do this right here. Now, when the value I got from memory is less than the current value, I'm going to transfer it to my little largest check register there, which is 20. So essentially what I'm going to do is move x21 to x20, and so that means this is data, looking good. Put some more comments in here. Look good. This is jump if not 0, and look at here. We'll put a comment in there. Is a new value less than an old value? Okay, and I just got to make these beautiful. And I think I'm done with the body of the thing. Okay, and then, yeah, so essentially what I need to do is save context. So, no, I need to do more than that. I need to, when I'm done here, before I save context, I'm going to say I'm done, because I actually have to doctor this up a little bit. And the idea is I want the return value, which is the largest thing, in x10, as the program asked me to. So this is x10. My largest value is x20. And we'll say x, make the red go away. And this is move this is what the problem requested, and then I'm ready to save context. So in this problem, what I'm going to do now is look at which registers I tweaked. So that's x15, 20, and 21. And we're x10 also, but x10 is going to be our answer. x15, x20, and x21. So that's 3 registers. So I'm going to make space on the stack for that. And SP, so there's 3 registers, so I need to make space for 12. And so I need to move it backwards, of course. And then I'm going to save these things. This is the nice part. Store word x15 and 0 p. I'm going to cut and paste these to save time. There's my 3 words. So it's x15, x20, x21, 4, 8. Okay, so there's my save context. Okay, so once again, I use 3 registers in here, so I have to save 3 registers. That's space for 12. I back the stack pointer up by 12, subtracting from it, and I store those 3 values accordingly. So one's at the stack pointer, one's 4 greater than the stack pointer, one's 8 greater than the stack pointer. So this works so nice. This is the nice part about it, is that when I come down here to restore context, I'm mostly cut and paste this thing, so okay, and we can call this nothing return. Okay, there's my return value. So move this up a little bit, fit it on the screen. So that issue here is I'm undoing what I did before. So you can see that I already switched it around. And lastly, this is a 12. So these are the three registers I stored them. When I saved context to restore them, I'm going to get them back off the stack. The same exact locations here. This is the nice part about cutting and pasting. I don't make mistakes when I cut and paste. And then I'm going to adjust the stack pointer accordingly. So up here I subtracted 12 from the stack pointer. Here I added 12. I'll say pop values push text. Okay, and at that point I'm going to call this done, and I'm going to see what this looks like. I know it's different from my solution, and the idea here is it has to do with this loop here. I actually did it differently. So this is a loop where I let it fall through, or I jumped back to the loop up here, which works great. So I'm gonna stop this and go to the other solution and point something out to you. Yep, here we are back at the other solution, and I want to take a look at this, and maybe I did it right, maybe I didn't. No, so I did it right. The big thing I was going to show you essentially is not in there. So I can't show it to you. So this is actually a good solution. What I'm going to try to show you is that, typically speaking, you can often model these loops in such a way that they don't need a unconditional branch in them, which a lot of our loops have up to this point. And so yeah, so anyway, it's not in here. No need to worry about it. Okay, folks. I don't know if that worked, but that's the way I write programs.